There are three identical circular tables with 5 chairs each. In how many ways can 9 people be seated in these tables such that each table has at least 2 persons? Consider circular arrangements with similar relative positions as identical. What this line says is that in a circular arrangement, ABCD is similar to BCDA because each can be obtained by rotating the other. And by identical tables, what's meant is that the tables are not distinguishable and therefore the order of the tables does not matter. So in how many ways can we distribute 9 people among 3 tables such that each table has at least 2 persons? There are 3 cases: 2 plus 2 plus 5, 2 plus 3 plus 4, and 3 plus 3 plus 3. We need to find the answers for each of these cases and add them all together. Let's consider the first case, 2 plus 2 plus 5. In how many ways can you form such groups of 2, 2 and 5? There are 9C 2 ways of choosing 2 people out of 9 times 7C 2 ways of choosing 2 people out of the remaining 7, and finally 5C 5 ways of choosing 5 people out of the remaining 5. So the product of all this would give us a number of groupings, right? Not really. Consider these two groupings. P1 and P2 form one group, P3 and P4 form another group, and the remaining form the third group. And in the second grouping, P3 and P4 form one group, P1 and P2 form one group, and the remaining 5 form the third group. You can see that these two groupings are actually the same. Since the question tells us that the order does not matter, these two are the same. It's just that P1, P2 has come here and P3, P4 has come here. So we'll need to figure out how many such repetitions are there for each correct grouping. If there are two groups of the same size, there are 2 factorial ways of arranging them, right? So we'll call this PA and this PB. And there are 2 factorial ways of arranging them, PA, PB and PB, PA. The first position can be filled in 2 ways and the second position can be filled in 1 way. So that's 2 into 1, 2 factorial. So each correct grouping is being repeated 2 factorial times. And so we have to divide this whole thing by 2 factorial to get our correct number of groupings. Similarly, if there were 3 groups of the same size, then those 3 groups can be arranged in 3 factorial ways. And so this would have had to be divided by 3 factorial. And so on. So in general, if there are n equal sized groups, they can be arranged in n factorial ways. And so you would have to compensate your answer by dividing it by n factorial. Okay, so in this case we have 2 groups of equal size, so the number of groupings is this thing. Now we'll have to see how we can arrange the number of ways in which we can arrange each group around the tables. Two of our groups have 2 people and the third group has 5. So let's see in how many ways we can arrange 2 persons around a table with 5 spaces. If there were 5 people, then we know that there are 4 factorial ways of arranging them around a table. But now we have only 2, so there are 3 blank spaces, and that makes the problem complicated. So what we'll first do is we will assume that the 3 blank spaces are actually 3 imaginary people. We'll call them B1, B2 and B3. So that would give us 5 people, and therefore there are 4 factorial ways of arranging them around the table with 5 spaces. Consider one of the arrangements where, while going clockwise, there is 1 empty space between P1 and P2 and 2 empty spaces between P2 and P1. Among these 4 factorial arrangements that we got, 6 of them would represent this same arrangement. right? All of these 6 represent the same arrangement where there is one space between P1 and P2 and 2 spaces between P2 and P1. So we'll need to get rid of all these repetitions. We need to find how many such repetitions are there. That's easy to see because here we have 3 empty spaces and 3 imaginary people, B1, B2 and B3. These 3 imaginary people can be arranged in these 3 spaces in 3 factorial ways, right? The first space can be filled in 3 ways, the second space can be filled in 2 ways, and the third space can be filled in 1 way. So there are 3 factorial ways of arranging the imaginary people in the blank spaces. And all of those 3 factorial ways represent one correct circular arrangement. So we have to divide this 4 factorial by 3 factorial to get the correct number of arrangements. Right? So in general, if there are n objects of which m are identical, then the number of possible circular arrangements is n minus 1 factorial by m factorial. That's exactly what we saw here. Here we have 5 objects of which 3 are identical, all the blank spaces are identical, and so the number of circular arrangements is 5 minus 1 4 factorial divided by 3 factorial. So for the second group too, there are 2 persons who need to be arranged around the table. So there are 4 factorial by 3 factorial ways of doing that. And for the third group, there are 5 people, and therefore there are 4 factorial arrangements. The total number of arrangements, therefore, in the first case is the product of all this. The number of ways of grouping them, the number of arrangements in the first table, number of arrangements in the second table, and the number of arrangements in the third table. Now the similar approach can be used for the other 2 cases too. When there are 2, 3 and 4, this is the number of ways of grouping them, since there are no 2 groups with the same size. This is the number of ways of arranging 2 people around the table. This is the number of ways of arranging 3 people around the table. And this is the number of ways of arranging 4 people around the table. Note that this is equal to the number of ways of arranging 5 people around the table, because when there are 4 people around the table, there is only one blank space. So all 5 are considered to be non-identical objects. Similarly, in the third case, this is the total number of groupings. You are dividing by 3 factorial because there are 3 groups of the same size. And therefore, there are 3 factorial ways of arranging those 3 groups. And this is the number of ways of arranging 3 people around the table. That will have to be multiplied 3 times because there are all 3 tables have 3 persons each. And finally, you need to add all these values. The answer I got was this. I hope I'm right. You can check it out.